Welcome back to the channel. And instead of being in the shop, I'm down here at the historic B&O Roundhouse in downtown Cleveland, where the Midwest Railway Preservation Society is restoring this Grand Trunk Western 4070 Mikado. There was a substantial crack in the frame of the locomotive that has been weld repaired over the last several months. The crack occurred years ago, decades ago, when the locomotive was driven into an open turntable pit. During the welding process, the frame is going to expand and contract a little bit, and that could pose a bit of a problem. These wedges here you see on the left side of the locomotive wedge the steam chest into the frame. And over here on the engineer side of the locomotive, you can see that wedge has been removed. And the reason why it's been removed is the last thing we'd want to do is crack the casting of the steam chest. It is an irreplaceable component. So by removing that wedge, when all the welding and heating and expanding and contraction is taking place on the frame, it virtually eliminates the risk that the frame will put any kind of pressure on the steam chest and then end up cracking it or ruining it. So my task now is to make a new one. So I'm using some calipers here to try to get some kind of measurements. The old wedge was gouged out with some carbon arc welding, and it's pretty much useless as far as it being a pattern. And I don't have any drawings that would have been made for this locomotive. So I'm kind of going by, rough measurements and my gut a little bit. And here is the original wedge, and you can see it's a little bit misshapen. The center of it's been arc gouged out. I have this piece of mild steel that should be just fine for this application. First thing I need to do is go ahead and cut this to a rough length on the bandsaw. With this now rough cut to length, I'm going to go ahead and get it clamped up in the mill vise here so I can start doing some machining and bring it down a little bit closer to what I'm hoping my target dimension is. I'll start with this 4-flute roughing end mill to square up one edge. With this one edge square, I'll go ahead and flip it around and square up the other edge and bring it to a rough length. This is not a tight tolerance part, so I'm just going to get a rough idea of what the original one was and try to get this one close. I didn't really care how that last end mill performed, so I have this corncob style end mill, and I'll use that to bring this down to length. With the end square and to approximate length, I'm going to go ahead and start facing this down to thickness. I've got this 3-inch face mill, and I'll touch off here. It's got 6 carbide inserts, and we'll probably take about 50 to 100 thousandths off on this first pass. I'm not super happy with the quality of this finish. I'm thinking maybe I've got a dull insert in there somewhere. I'll address this later when I start bringing it a little bit closer to dimension. But right now what I need to do is bring it down height-wise to dimension. I'm going to try to get this squared up at least, because even though it's getting wedged into a casting, between the frame and the steam chest, there is some level of precision in which it needs to be tight enough. It can't be too loose. So I want to try to get it as close to the original and to my measurements as I can get. I have quite a bit of material to come off of the height of this piece. So I just took a cleanup pass here on this edge. The surface finish on this certainly did come out better than on the other edge, but right now it doesn't really have to look pretty. I'm just going to try to get it square. So I'll get it out of the vise so I can deburr the edge and continue the operations to get this square and to size. You can really see here just how bad that surface finish is. I know the head is trammed because I checked it. So I'm not exactly sure why it looks this bad. I'm pretty sure it's probably a bad insert. Either way, I'll flip this over, put the wire back in because this isn't quite square yet. And now I can take this side, get it nice and square and down to size. If you look closely, you can see how the face mill is sort of rolling over and raising a burr on that leading edge of the cut. And that can be caused by a number of different things. And I think what's happening here is I've got at least one dull insert. But I am going to persevere at this point because I'm under the gun on this. I'm a bit late in getting this project complete. And they need this in order to get that frame put back together so they can move on to other things with the locomotive. And that raised up a very nasty burr here on this backside of the part. And again, I think that's because of a dull insert. I don't think it's the material, although it certainly could be. All right, I have this deburred, and I've got a mock-up of the wedge here. And if you look at this 3D printed sample, yeah, it's square on two sides, but on the other sides you have this tapered edge, and then it's also rounded over. So I made these, 3D mock-ups just so I could test to see whether or not they would fit in the existing wedge opening. Now I've got to machine that rounded over and that taper, but first I want to see what really is the original radius. I've got Mitutoyo radius gauge here. I've got a 1/2 inch radius, and that looks pretty close. I think it is definitely a 1/2 inch radius. So I need to machine that radius into this part, and that might be a bit tricky. All right, so how am I going to cut this round over, this 1/2 inch radius round over? I don't have a tool already that is going to do it for me, and doing a custom grind on some high-speed steel is not really an option either. But what I'm going to try is maybe a little bit unorthodox, but here I have a carbide router bit. This is for woodworking. I just bought this off of Amazon. It wasn't that expensive. If I destroy it, so be it. If this doesn't work, I'll go to plan B. But for now, it's just a carbide. I believe it's a carbide, brazed carbide round over bit with a ball bearing on it. Yeah, I guess we'll see how this goes. So I think the way that I want to cut this here is I'm gonna touch off on the top of my piece with the round over bit, and then I'll feed the saddle into the cutter rather than feeding it up. I think that might work well for me. I am going to use my mist coolant, even though I hate the coolant that I'm still using. I still haven't gotten around to getting some cool mist. Again, I don't want to buy a gallon of it. I know a viewer in another video posted that you can get small quantities from another website. The trouble is the shipping on those small quantities is actually more than the product is. So I might just go ahead and get a gallon of it, and I'll have it forever. Well, there's nothing left to do but to do it. So I am going to just take this slow. I'm not going to take too heavy of a cut. I don't want to break this cutter. It's the only one that I have. And if this works, great. If it doesn't, I'm not going to do anything that would at least prematurely end the life of this cutter. If it works, I'll be super happy, but I don't want to intentionally do something that might be a bit reckless. So just kind of taking my time, trying to get this mister set up to try to keep it as cool as possible as to not burn up the edge of the carbide. I do think maybe I was being a little bit conservative here, so I'm going to take a little bit of a heavier cut before I complete this first pass. Well, that seemed to go okay, but I do want to redirect this mist coolant so it's coming in from the front. I think that's going to be a better location than spraying it from the back, especially since I am kind of making it a bit wet versus, a true mist. It's more spitting at it than it is misting, which I kind of prefer the spitting more, just to keep some of the coolant from atomizing too much and end up in the air more than it needs to be, because I don't want to breathe any more of this in than is necessary. Well, so far this is working exceptionally well, and I'm really happy with the results. So I think this is going to be my last pass, and I should have a good 1/2 inch radius round over on one corner of this thing. Yeah, that was the final pass. That looks really good. I don't think I could really be any happier with the result. I mean, who knew that you could use a woodworking bit in a metalworking machine? It is a bit interesting that when I compare it with the radius gauge, it doesn't quite look like I got a full radius on there. I don't think that's going to be a problem, because if I compare it to the original Wedge, it lines up. So I'm not sure why this looks like it's a little bit off, but I think it's going to be fine. I need to figure out what the taper is on this rounded corner between the bottom and the front edge of the Wedge. So I'm using a protractor here to measure that angle. I'm going to use the K&T 2HL horizontal mill to machine that taper because I can. And I don't really want to nod the head on the Bridgeport. So I've got the vise that I normally have on the Bridgeport here mounted up on the table of the K&T, and I need to get it trammed in. So I'm going to use the universal milling head to machine the taper. And the first thing I need to do now is to bring the milling head off of its parking attachment with the crane and get it mounted up on the front of the machine. And you might think this is fairly straightforward, and I wish it was, but it's not. But I still think it's better than tramming in the head of the Bridgeport. I might actually disagree with myself at some point here, because this does take quite a bit of work to get this thing mounted and set up properly. Once it's unloosened from the parking attachment, I can use the crane built into it to swing it around to the front. I have to reinstall this dovetail clamp. I take this off so it fits on the parking attachment a little bit easier. Next, I have to set this on top of that drive gear so it meshes with the gear that's in the bracket for the universal head. And again, this is a little bit tricky. The crane lets you move this up and down. But in order for me to get it on and off the parking attachment, I have to adjust the height of the crane with that. So I can't keep it set for this, for mounting it on the front. I wish I could leave the crane set in one spot the whole time, because it would make this process a whole heck of a lot easier. But even getting it set on that gear is only the beginning. And of course, I'm trying to do all this with the universal head over to the right, which makes it a little bit off balance. Now, a smart man would go ahead and loosen those mounting bolts on the front and let it swing down underneath it and kind of give me a little bit of equilibrium here, but I'm not a smart man. Now that I kind of sort of have it mounted on the front, the next thing I need to do is get it lined up so I can push the overarms into this support bracket, and getting that lined up is a bit tricky. Getting these overarms into the support bracket is essential, because it really is what provides a good bit of the rigidity to this setup. You'd figure as many times as I've done this, I would have come up with something that would make this process a little bit easier, but I haven't. That was actually quite a bit of work. I cut out a lot of the footage from this process, but now that those overarms are fully seated into the support bracket, I can now tighten everything down and make this good and rigid. I can now loosen these mounting nuts here that hold the milling head to the swivel. Because of the nature of this particular device, this universal head, I do lose quite a bit of table travel. And because of where I have mounted the vise, on the milling table, I really need to flip this over so that the milling head is on the left side of center. Well, using the protractor on the side of the swivel, trying to get it lined up on 90 and tighten these nuts here, which is a little bit easier said than done. Well, that's pretty close. Take a rubber mallet here and kind of tap it till it's a little bit closer. I don't trust this protractor. I will be indicating in the head here in a little bit, but I want to get these nuts here tighter, at least right now. Same thing with the milling head here. I want to get this dialed in to I think it was 7.5 degrees. I can't remember which, for that taper, and then tighten these down. I am going to use the same 3-inch face mill, but I moved it off of the R8 shank over to this NMTB 40 tool holder. Get the machine powered up here and check the direction of the spindle, and yeah, it's running in the wrong direction. So there's a reversing handle here on the gearbox that I can use to reverse the direction of the spindle. Now that we got it going in the right direction, we can start machining this taper. I still haven't changed out the inserts on this face mill, so I'm still getting a bit of a crappy surface finish. Well, I think that's going to be it for the machining. A little bit of deburring here, but if I compare the shape and everything to the mock-up that I made, now I did take this 3D model out to the roundhouse and test it in that gap, and it seemed to fit in that gap a little bit tight, which, I'd rather take a little bit more off the width of this thing than try to figure out how to make it thicker. So I did make this slightly oversized, which is, again, fine. That's what we wanted. So I'm hoping that it'll go in without any problems. Well, since I started this project, the locomotive has since been moved outside, and it looks like this might be a little bit tight, which, again, I think the geometry on it is correct. Whether or not the dimension of it needs to be slightly altered, I don't think that's going to be a problem. But unfortunately, I'm not going to be able to install this today. I'm going to have to leave the installation of this to the project team when we're all back together. So I don't think I'm going to be catching that on camera. If I do before this video goes out, then I'll certainly try to do that. But this is just one step closer to getting this locomotive back on the rails and running. If you'd like to learn more about the Midwest Railway Preservation Society, there is a link down in the description. Volunteers are always welcome, so come on down to the Roundhouse and lend a hand, help us get this locomotive back in running condition. That's going to be it for this video. I hope you enjoyed it. If you did, give it a thumbs up. Go ahead and leave me a comment down below. Let me know what you think. If you'd like to be a subscriber, hit that subscribe button. It costs you nothing, and if you hit that bell icon, it'll notify you whenever I publish a new video. If you'd like to support the channel in other ways, there are links down in the description where you can do just that. Thanks for watching, and we'll see you on the next one.